Hello, and thank you for joining us. Welcome to this presentation, which is part of an ongoing monthly Goose webinar series exploring issues and projects associated with global sustained ocean observing of essential ocean variables. I'm Albert Fisher. I'm the director of the Global Ocean Observing System Project Office based here at the Intergovernmental Oceanographic Commission of UNESCO in Paris, and I'll be moderating the webinar today. During the next hour, we'll start with a 30-minute presentation on moving towards essential ocean variables for biogeochemistry. And after the presentation, we'll conduct a question and answer session by chat. I'll moderate and select and ask the questions verbally, and I'll try to select questions that are representatives, and we'll try to answer as many questions as time permits. The chat window is already open on the lower right-hand corner, and you can ask questions, clarifying questions during the presentation. I'd also like to let you know that this session is being recorded, and a link to the recording will be posted on the Goose webpage, where you can find also our previous webinars. So our presenters this month are Tanhua and Maciek Telszewski. Tosta is the chair of the SCORE IOC International Ocean Carbon Coordination Project, the IOCCP. His research is on tracers, on ocean ventilation and mixing, and he has a PhD in marine chemistry from the University of Gothenburg in Sweden. After some time at the Scripps Institution of Oceanography in the US, he's been working in Germany at Geomar in Kiel since 2002. He's also a member of the Global Ocean Ship-Based Hydrographic Investigations Panel, or GOSHIP, which coordinates repeat hydrographic missions globally. And Maciek is the director of the IOCCP office, which started at the IOC here in Paris and is now based at the Institute of Oceanology of the Polish Academy of Sciences in Sopot. He received his PhD from the University of East Anglia in the UK and has also worked in Japan. His research was focused on marine carbon cycling and air-sea fluxes, and he's been with the IOCCP since 2010. So without any further ado, I'd like to turn it over to Tosta and Maciek for the presentation. Thank you.
Hello, good morning, good afternoon, and good evening, everyone. Thank you very much for joining us for this session, 60-minute session. I hope you'll find it useful, and I hope that you will be able, or some of you will be able to contribute to the work that IOCCP has been leading over the last 14-15 months. As Albert introduced us, my name is Maciej Telszewski, and I'm project director for IOCCP. And this talk is going to be divided into two parts. I will give you a background of IOCCP very shortly, but also a background to why and how we got involved in drafting a set of essential ocean variables for biogeochemistry. And then Tosta will fill you in on details on how this exactly happened and what are the outcomes of this work. So for those of you who never heard of IOCCP or just briefly heard the name, the IOCCP stands for the International Ocean Carbon Coordination Project, and it's been around in one form or another for the last 60 years, more or less. It started shortly after IOC and SCORE started its work, and these both are our parent organizations, and they were both strongly focused on coordination of ocean carbon observations since their early days. And they called for a panel of experts, which then turned into another panel of experts. And when the coordination got much more significant a task, both organizations decided that it's time for IOCCP to become a standing project with secretariat, and this happened in 2005. Very broadly speaking, IOCCP provides service and help to the ocean carbon community, and recently to the community of observers of carbon-related variables. And we do that through brokering and helping with implementing standards, measurement standards, data quality standards, methodology, and also we try to link to other observing networks and elements of the global ocean observing system. As you can see on the left-hand side of the slide, We divided our mission into several tasks, and we coordinate work on the underway CO2 observations, and this leads us to coordinating the surface CO2 data, or helping to coordinate surface CO2 data, collection, quality control, and distribution, ocean interior observations and ocean interior data, time series networks. We have focused on instruments and sensors for carbon and wider biogeochemistry, ocean acidification, with the caveat that we look into coordination of large-scale global observations. We're not getting involved in the lab experiments or mesocosm experiments. We look at the larger scale stuff. And in 2 years ago, the GOOS steering committee asked IOCCP to help with implementing of FOO by becoming the leaders of the biogeochemistry panel of GOOS. And the IOCCP SSG, after some negotiation, decided that it's something that we could do and we would like to do, but to be able to do it, we would need expertise in non-carbon biogeochemical parameters on the panel, and therefore we asked a nutrients specialist to join the panel, Michio Oyama, and we will soon get involved more in the oxygen work in terms of global observations. So this is what we do, and one more slide. I thought it's relevant to show how we approach our mission, and that's because it's the way we work is very much aligned with the framework for ocean observing, and I guess most of you have heard of the framework for ocean observing, and I will not focus too much on it. There was a webinar on the full details in the past. So what we do basically, we start by looking at the societal or scientific requirements for certain observations. Once those are established, we help colleagues to develop strategies for observing network implementation, be it connection with other existing observing network or advocacy for developing of new elements and platforms. Then this leads to brokering standards on measurements, quality, data quality, and validation procedures, and quality control procedures, obviously. And when we have data, we very much focus on developing data synthesis products. IOCCP obviously doesn't do that on its own. We try to help colleagues do that. However, it's very important part of our mission that the data that are being collected globally for years and years are actually being put together in a synthetic product that can then be fed into a very broad stakeholders community, and these stakeholders might be a decision-making community, public, modeling community, etc., etc. And by doing that, we are able to validate whether the whole cycle is fit for purpose and whether the requirements that are set are met by the observations coordinated by IOCCP. And in 2009, some of us were in Venice during the Ocean Ops 09, and there was a conference-wide call for new, improved, enhanced global ocean observing system that integrates the physical, biogeochemical, and biological observations. And so since then, it was clear that IOCCP will play a role in developing and then implementing this new way of measuring, which is integrated across disciplines, basically. And as I said, I will not focus on the FOO, but this is a very simple view of the framework of ocean observing. So in orange, you can see the requirements element. So this is where the community or various communities establish what are the questions, the societal needs or scientific questions that need to be answered. Then what needs to be measured to answer those questions, and these are phenomena, processes that need to be measured. And to be able to measure those, we need variables, and we call those essential ocean variables. I think that the essential it's an important part here, because we try to find such variables that are applicable in most places and that can answer the most number of questions. Obviously, you always have tails on both sides, but this is about the global, sustained, long-term observing, and hence a smaller set of more applicable variables is envisaged. In the purple, you have various, you have the visualization of
Maciek, I'm just gonna,
yes, Albert?
I just wanted to interrupt. I was ask. There's a couple of requests to get closer to the microphone. Can you get as close to the microphone as possible so people can hear?
Is that better?
It hasn't really changed, no.
Okay, okay, so maybe my Jabra is not working. I'll try to get closer to my computer. Is it better now?
That's much better. Thanks.
Okay. Okay, so I'm sorry for the sound quality. I'm using the external mic, which apparently is not really working. So I'm now very close to my computer, which means that you probably see a massive face of mine. Doesn't matter. So in purple here you can see existing elements of the observing system, you know, ships of opportunity, satellites, etc., etc. And all those put together need to be used in order to measure whatever we decide that needs to be measured in 3D or 4D space. Once the data is there, similar to what I showed a couple of slides ago, there is a data assembly effort and data products, which again is very important for policy making community, decision making community. And there are two arrows, schematic arrows from green to orange, and they visualize the feedback loop that's there on two levels. One is the decision making level to assess whether decision makers actually use this information, ocean information, in their decision making process. And then the second level, which is on the observer level, visualizing the way that we can assess the validity of our approach and fitness for purpose of the whole system. And here we can see the structure of the framework for ocean observing. There are three levels, and the top level is there to advocate the use of global ocean observing system information. Is there to also connect to various sponsoring bodies, peak bodies, and the leaders, including United Nations system. In the middle, you have the observing system panels, and this element is responsible for developing on of essential ocean variables. And as you can see, IOCCP is there to show the biogeochemistry element. There is a physics group and biology and ecosystem group. And altogether, we hope to have to develop a set of essential ocean variables that would be multidisciplinary and that would be able to answer existing questions. And the most important part of the whole system is the technical advisory groups, in my opinion, where these are colleagues focused around technologies, networks, platforms, communities of practice, basically, and data archiving systems and modeling, etc., etc. So this structure means that the panels in the middle need to be really looking into the observing system, but also up to what are the requirements and what are the needs of the community at large. And about a year ago, the IOCCP agreed to provide a certain contribution to this to the whole process. And IOCCP from the very beginning decided that this is going to be a community effort, and we are leading it. The scientific steering group is leading it, but we hope for as much input from the community as possible. And this work was divided into four basic steps. First, we tried to collate the then available information on societal and scientific requirements, so the very top level. And this was done, by literature search, but also a wide net of email exchange with leaders in communities. Once that was done, we contacted the institutional partners, programmatic partners, to ask them for their input, and also to ask them to help us with the multi-dimensional feasibility assessment of the proposed parameters. And this sounds a long sentence, but this is all described in the FU very nicely, and the FU document tells us about things like readiness levels, feasibility, impact, etc., etc. And in the whole process, we try to follow the FU guidelines, a systematic approach to developing the essential ocean variables. We then led this initial multidimensional feasibility assessment, and Toste will tell you more about the details, because this is actually the meat of the webinar. And we obviously build the whole process on the full recommendations. And the final element, we promised to produce a summary publication, not peer-reviewed at the moment, available on our website, the draft of it. We presented the report during the town hall organized in Honolulu during the Ocean Sciences meeting. And also this webinar is part of this presentation as well. And each time we present this work, we definitely say, please contribute, get involved, nothing is set in stone, and there's a lot to improve. A couple of slides before I'll give microphone to Toste, who I hope will have a better technical support. So we have 5 years before Ocean Ops 2019, and in the FU document, talks about the next decade, which means that we have until 2019 to implement at least elements of the FU. And in 2 years, we hope we will have a clear statement of requirements for observations. We think that we have a good draft of this statement already, but as I said, there's always a lot of space for improvement. We hope to have a set of agreed EOVs for biogeochemistry, and the slide says 10. It's a good number, but if it's 8 or 12, it doesn't really matter. What does matter a lot is that there will be a community-shaped, widely reviewed, and obviously well-reasoned. So if we are hoping for implementing of the FU globally, we really need a global agreement on the EOVs. And the beginning of the implementation driven by feasibility and impact, obviously. So the highest visibility and feasibility, and highest impact first. We hope to find champions locally and regionally. And also we hope to start implementing the Global Ocean Observing System locally, that's based on the full system approach. So starting from observations, starting from requirements actually, through observations, through data systems, and then linked to data analysis that leads to data synthesis product development, which can create what some call actionable information. So information that decision can be based on. Partnerships, all this will only work if we implement this approach globally. So our partnerships to conventions and assessments through GOOS and through elements of GOOS are a big hope for the next 2 years. And in 5 years' time, so in time for Ocean Ops, We hope to have the full cycle evaluated at least once, and it's going to be a living process. So EOVs will probably come and go, but we would like this first round to have finished by OceanOps 2019. As usual, a very difficult task to energize communities of practice in the coastal space. There's lots of issues regionally and locally with looking at the global scale for colleagues working in the coastal ocean. But the hope is that focusing on EOVs rather than technologies, platforms, etc., might help us energize those communities. We hope for some pilot projects that would show that the full approach works, and particularly integrated with the other two panels, physical and biological panel, so that we can show that in 10 years we came up with a way to provide the community with the integrated global ocean observing system. And most of the work happens before, during, and after the expert workshop that we organized together with Bruce and a few other organizations in Townsville, Australia in November 2013. There were two groups there. One was biology and ecosystem panel, and one was biogeochemistry panel. And we met mostly in parallel sessions, but we had a couple of plenary sessions every day to exchange and cross-fertilize. As for biogeochemistry, we had 12 experts, modelers, including observationalists, colleagues working with inorganic carbon, colleagues working with biology, colleagues working with tracers, etc. We tried to cover the whole range so that the outcome, the essential ocean variables, would be well validated against various subdisciplines. And with that, I will mute myself and give the mic to Toste.
Okay. Hello everybody, this is Toste Tanhua. I'm calling from Geomar in Kiel. And thank you, Madik, for the nice introduction to our work. So I will take you through the process of actually defining the essential ocean variables for biogeochemistry, pretty much based on the outcome of the workshop in Townsville. After that, we put the result from the Townsville meeting on our website, and we had a 1-hour township meeting during the Ocean Science meeting in Honolulu in February this year, which had about 100 people attending, and we got several ideas from that. And that was the second step in reaching out to the community, asking for input, and this seminar here, or the webinar, is actually the third stage of that process that is moving on. So the way we did that in Townsville, we started along the full concept of defining and talking about the scientific requirements and societal needs for the global ocean observing system, because that is the only way that we can justify the high cost of observing the ocean. And these are the three major themes that we came up with. This is nothing new, has been done before, but it was useful to do it. So I'm going to read this out for you. The role of ocean biochemistry in climate. And there are two questions here. How is the ocean carbon content changing? Obviously very important for the greenhouse gas, carbon dioxide, and the concentration in the atmosphere, but also the influence of non-CO2 greenhouse gases from the ocean into the atmosphere, and how that is possibly changing in a changing climate. The second important issue here is the impacts from humans on ocean biogeochemistry. And one major issue is actually the oxygen minimum zones, or dead zones as I call them here, which are in some places probably expanding due to different reasons. Another important issue is rates and impacts of ocean acidification. And the third major theme here is the ocean ecosystem health, where some things are landing more on the biogeochemistry panel. And one here is the biomass of the ocean. how is that changing over time? Another one is eutrophication and pollution, how that possibly impact productivity and quality of the ocean. So once we had that nailed down, or had an idea of what we wanted, we started to think about what do we actually need to measure in the ocean? What are the essential ocean variables to be able to answer these questions? So I'm going to read this out for you for the first question here, the ocean role of biogeochemistry in climate. And if you want to understand how the ocean carbon content is changing, it's obvious that you need to measure the carbonate system, but also the organic part of the carbon system, transient tracers, oxygen, macronutrients, carbon isotopes were things that this group of experts thought were the most relevant ones to measure. And there will obviously be a lot of variables that are needed to support this, like salinity and temperature. I will come to that later. The second question here is the ocean influence on non-CO2 gases, and these are then the gases: nitrous oxide, methane, DMS, halocarbons, and other ozone depleting substances, and oxygen. And I put some pictures in here of a ship doing time series measurements, which is an important component for biogeochemistry in the ocean. And another picture showing sampling for transient tracers for offline measurements. So we will go on here with another questions: the size of oxygen minimum zones and the oxygen content of the ocean. And you see a picture of somebody shaking a Winkler bottle, which is the only reference measurement we have of oxygen in the ocean, apart from having very nice optodes and other sensors. So when it comes to ocean acidification, we see clear two different sub-questions here. The one is related to detection of the acidification, and the other one is related to impact of acidification. And I won't bother with reading out all the variables, you can read them yourself. I'm gonna go on here to the question of ocean ecosystem health, and the question on how the biomass in the ocean is changing. And here again we kind of refine the question and ask the question about changing production or changing biomass. And we have a picture here of a sediment trap being deployed, and another picture of, in the lower right corner, of the underwater vision profiler that is mounted on a CTD package that gives you an idea of particles, zooplanktons and other particles in the water column. Going on with the ecosystem health, so the question about eutrophication and pollution can then be split in the eutrophication part and the pollution part. And that group of experts that met in Townsville, none of us were really experts in the pollution part here, so that is certainly something that we can improve on. But anyway, now we have identified the questions we need to answer, we knew what we need to measure, and then we started to rate these things and came up with this diagram, feasibility versus impact. And obviously we want to spend our money on measuring something that has a high impact, but also something that is feasible. So on the upper right corner, where that is the case, you see a few green dots here. And those are the variables that are listed as the most important one for many of these questions. And then we had another discussion and talked about it again and rated them. So these are actually a list of EOVs for biogeochemistry: the carbonate system, macronutrients, oxygen, particle matter transport, suspended particulates, transient tracers, stable carbon isotopes, carbon-13, and dissolved organic matter. The dot on biooptics is red because we it was very highly rated by us, but it's not really variable, and it's possibly more related to the biology and ecosystems panel. So this again is the list. It's not top 10, it's a top 9 pick of essential ocean variables. So that is just a list. Doesn't really tell you that awful much. So the devil is in the details, as always. And each of these EOV has a specification sheet consisting of several pages, and we have filled this out in the first round, and we're now asking for input for these specification sheets. These are probably important for policymakers and program managers, and I'm just going to run you through some important things that we actually talk about here. So this is the basic information of the EOV. We're talking about the carbonate system. So we have 4 subvariables that you can measure: dissolved inorganic carbon, alkalinity, PCO2, and pH, and we need to measure 2 and 4 out of those. We have derived products, like in this case the saturation state of aragonite or calcite, dissolved carbonate ion concentration, the flux of carbon dioxide. You can derive anthropogenic carbon content, or you can derive the change in total carbon. So those are products that you can get from these measurements, and to get to that you need a number of supporting variables. They are listed here, some of them. And there is also a contact lead expert here, and normally there is a little bit of text in the top here to describe the EOV. Then we're talking about the requirements. In this case, for oxygen, we talk about the responsible goals panel, societal drivers, and scientific applications related directly to the questions I just went through. As everything here, we're talking about the readiness level, which is an important concept of the FOO. For oxygen, we think that is immature. We know pretty much why and how we need to measure oxygen. Then is another very important thing of this is actually the phenomena that we need to capture. For oxygen, we're talking about RC fluxes of oxygen. We're talking about changes in storage of oxygen. We're talking about the extent of hypoxia, suboxia. And we're talking about net community production. So these are the phenomena that we want to capture. Next line here has these temporal scales. They all occur at different temporal scales, which is important to understand. They all have different spatial scales listed on the next line. And there is also a magnitude range of that signal that we want to capture. So for instance, on the second column here, in changes of storage of oxygen, we're talking about 400 teramoles per decade. And for the last line here, we have a design detection limit relative to the signal. And we're saying that it would be nice to know how much the oxygen is changing by plus minus 10%. So that is our goal. That means that we need to be able to measure down to a certainty of 40 teramoles per decade in the total global carbon content. So those are our aims and those are our goals, and you can do that for all different phenomena here. And to the right you see the diagram here, how you can visualize these different phenomena on a scale here. This is actually on time scale on the y-axis, going from 1 hour to 100 years, and spatial scales going from a few meters to the left to a global scale to the far right. And then we go into the trade space, the observing elements, and these are the current observing elements for oxygen. So just go through here. We have profiling floats, we have repeat hydro, which can be read out as any hydrographic ship-based hydrographic effort. We have moorings, gliders, and ship-based time series. These all address different phenomena. They all have a different readiness level. We want them to be mature, but some are actually on pilot state. And these different observing elements are good in capturing various spatial and temporal scales, which is important to understand. They all are able to produce or measure various amount of supporting variables. They all based on different sensors and technologies, like optical oxygen sensor for the profiling floats, which you see up on the picture on the right. For moorings, you use the same kind of experiment. For repeat hydrography, you can use biochemistry, Winkler, and sensors on the ZTD package. All these measurement techniques have different accuracies and uncertainties, which are important to understand in order to deploy them to cover the requirements that we have set up. These can all then be visualized in the same kind of diagram of spatial and temporal scales, where you see a long skinny thing for moorings, for instance, on very small spatial scales by covering a very large temporal scale, and so on. We also do the same exercise for future observing elements, and these are usually things that we are seeing coming, or experts are seeing coming, and will be useful complement to the observing system, but they are still on a pilot or concept phase. One of those for oxygen would, for instance, be observing ships of opportunity and gliders, although gliders is relatively major in this case. So we also do a little bit of exercise on data and information creation here, going from the old carpenters say of measure twice, cut once. Defoe is saying measure once and use many times. So for oxygen again, here we see on the top row what we talk about here: oversight and coordination, data control, data quality control, data management, data stream, delivery, and data product. And then we define all this for the different observing elements, like the profiling floats. So we have the bioargo array, that is oxygen on the argo floats, and we thought that the readiness level of that is on the pilot state, and so on for the different things here. Obviously, this table is not quite filled out then, and that's actually where we need your input, and the input from the people on the expert panels here. And the last page here on that specification sheet is also some useful links and references, in this case to some white papers for the Ocean Ops meeting, some contributing networks, and links to where you can actually find the data. This is just the first draft. We are certainly missing a lot of things here. So I think this concludes the presentation from me and Magic. I hope you got a gist of it, and we really want to reach out to the community for inputs of any of this. Please send us emails or go on the website. You can go to the website and download the EUV specification sheets that I just went through, and also the report from the Townsville meeting. We are really looking for input from you on this. The next step in the process of EUV will be the GOOS Scientific Steering Committee meeting by end of July. So it will be good to get some input from you within the next month or so. And I think I'll leave it now to Albert for the question session. Thank you.
Thanks very much, Tasta. Thank you, Maciek. And I encourage you all to ask questions. Some of you have started already in the chat window, and the chat window has grown in size at the bottom of the screen. So please ask your questions. And in the meantime, we've had some questions, in fact, 2 questions about where this data is available. Howard Freeland has replied in the chat for the bioargo data. And as you saw, the templates that the IOCCP and the experts have filled out do have links to where data is available. You can get those templates in their draft form at the website that's on your screen, www.ioccp.org. But maybe I could turn it over to Tasta and Maciek to answer that question about data and where this type of data is available, and is it available for all of those essential variables that you've identified?
Okay, I can maybe answer that question. We have started to fill out these forms where we know the data are available, but they are incomplete for sure. And that's where we like to have the community input on that. So please check the specification sheets for your favorable EUV and give us feedback. That we would appreciate.
One more comment is that there was a question about the CO2 underweight data specifically, and this data is definitely available from SOCAT and from CDIAC. If you go to the specification sheets, you'll find it, and these are traditionally our, this is the carbon, so it's IOCCP's traditional area of expertise, and for the other data, obviously we are in some cases new to the game. And one more comment is that if you download the specification sheet and want input, please send us an email, because we are in the process of updating them, in some cases quite significantly. So if you actually want to make an effort and help us, it would be great if you had the most up-to-date versions, which we would send you immediately. Thank you.
So Tosta, I have a question for you. You listed 3 questions that were your overarching questions in defining the biogeochemical EOVs. First sub-question related to that is, in fact, some of these questions also have impact on physical and biological variables. And maybe you could tell us a little bit in Goose who's responsible for the physical and biological variables, and how you plan to work with those other panels in having a rational set of essential ocean variables.
Thank you, Albert. That's a good question. It's not a clear cut between the physical panel, biogeochemistry panel, and the biology ecosystem panel. For instance, I've been talking about the transient tracers as a biogeochemical essential ocean variable. It actually ended up very high on our list. But in the real world, that is maybe better handled by the physics panel. The same thing is, we talked about chlorophyll as an important parameter to measure in order to understand productivity in the ocean. But we kind of felt that is probably more on the biology ecosystems panel to handle that. So there's going to be vague definitions here, and we need to decide on which panel is actually responsible for which here. Obviously, biogeochemistry depends heavily on some physical variables like temperature, salinity, stratification, etc.
And then the second question associated with those questions that you listed, the 3 major questions, those are actually largely scientific questions that have societal impact. And so when you talked about, it was Maciek that talked about completing a full cycle of evaluation of the fitness for purpose within 5 years of the biogeochemical observations of the ocean under Goose. Who do you see as your user that you will be consulting with? Is this really primarily the scientific users, and how in the context of Goose do you plan to connect to more societal users of ocean carbon information, which may be through conventions, through assessments?
I think that we are still in a phase where we're reaching out and trying to understand that better. The scientific community is certainly very important. I think things like the IPCC report is certainly a very important piece of information that these observations have impact on, particularly for the first major question, the ocean role of biogeochemistry for climate. But it's not so clear-cut for me at this point how that feedback loop will go onto stakeholders in terms of providing that feedback. I think that's something that we will exercise within the Goose framework or the FOO framework.
Okay, let me ask a little bit more of a technologically oriented question. So you had a chart where you evaluated the feasibility of measuring sustained measurements of certain biogeochemical variables, these candidate essential ocean variables, versus the impact, the importance of that variable to answer the questions. And are there variables that you think will emerge with new observing technologies as being more feasible, and therefore as new essential ocean variables? And where do you think sensor developers should put their greatest efforts into improving the feasibility?
Good question. I think for sensor developments, I think they should target those essential ocean variables that we have here, that is micronutrients and the carbonate system. and whatever bioptics or optical instrument that you can have for particulate matter transport or particulate matter load. Emerging variables will certainly come up there, so that will be things that have a high impact, and that will be carbon 14 on my diagram, and there are two other variables that I just don't know what they are. They have a very high impact but a low feasibility. So moving things from left to right on that feasibility diagram is certainly something that we would like to do. Okay, I think somebody is getting that diagram up on the screen.
Yeah, I'm flipping back on your talk. There it is.
There we go. There we go. So it's hard to see on that small here, but there is something over here which have 2 and 7 on it. Those are things that have high impact but low feasibility. So yeah, this exercise will actually identify and target those, although I don't know on top of my head what those particular ones are. Carbon 14 is certainly one that would be very useful to have if the technique was out there to do it more cheaply.
And then another question, you had a slide, and I'll try to flip forward to it now, that showed the space and time scales measured by different observing platforms. Here it is. It's again pretty small because it's in the lower right-hand corner. So for example, ships is the very vertical-looking bar that has very high time spatial resolution and measures on various different scales. What I found interesting in this one was that VOS, the voluntary observing ships, so commercial ships, covered a huge, potentially, space and time segment. And so I'm wondering what do you think is what are you collecting now? What variables can you collect now from voluntary observing ships, and what's the potential there?
Okay, so we are thinking of carbon dioxide, PCO2, and the corresponding salinity and temperature, obviously, for those. But we're also talking about ferry box systems measuring nutrients and oxygen, possibly carbon isotopes, nitrous oxide can be measured on VUS. Obviously, you only typically get the surface water and gas sea exchange parameters on that. There are some really interesting techniques on the cavity ring down spectroscopy, doing carbon isotopes, nitrous oxide, carbon monoxide, carbon dioxide, things like that. That is something that will probably be could be utilized much more on the US ships in the future. And basically the ship-based time series here is that vertical bar together with moorings, whereas repeat hydrography is kind of a more small circle up to the right here, where we're talking about pretty large temporal and spatial timescales, but with high quality reference measurements of all the UVs. And that is actually even now one of the few ways of getting high quality biogeochemistry measurements in the ocean.
Thanks, Tasta. We have a question from Hernan, which maybe I'll ask to Maciek, which is, it would be very highly desirable to come up with international quality controlled ocean database of biogeochemical variables. And Maciek, maybe you could tell them about some of the databases that are available through the work of the IOCCP, and just give us a little overview of what's available and what might be coming.
So Hernan works closely with CDAC. So the traditional database of the quality controlled or first level quality control database for carbon parameters was CDAC. And in 2007, the community decided that we need to second level quality control, meaning that we as a community go through all the data and find data that's wrongly put in the wrong places, or that is outliered, or that doesn't really fit the region, and find out why there are failures in instruments, etc., etc. So I think the second level quality control is what Hernan is asking for. And it's a tremendous effort by a very large community. The paper that's been published on this data set called SOCAT has 80 authors, and some authors were excluded because they didn't do the research anymore, etc. So it's a massive effort by a lot of people, and it's been done for one parameter, essentially for PCO2. Now, once SOCAT was published for the first time in 2011, some people got really excited about the idea, especially that it came with a whole set of tools that can be used to visualize the data in various forms, and the visualizations can be downloaded, the data can be downloaded, also in various forms and formats. Community started asking SOCAT team to include more variables, so more or less what Hernan is asking for now. And the slight problem with this, the problem that actually prevents us from expanding SOCAT at the moment, is that all this work was done voluntarily. So almost no one was paid to do that. There are 10% of person years here and there, but other than that, the leaders of the community have done this quality control in their free time from 5 to 9. And to do that for any other parameter, you would need to count on this input again. And SOCAT is now 7 years old. The third version will be released next year, and one can see a little wear and tear in the community, because it's only so much time you can actually spend on doing things voluntarily. So I agree with this question. It would be fantastic, but it needs to be bottom up. It needs to be community driven, and one needs to find a group of champions that would actually push the idea forward. And I think that's it.
So Venkatesan has a question about the spatial distribution of observations that are required. You do have some information in your templates about the space and time scales that are required. But are there some known hotspots that you know from either modeling studies or from having done the biogeochemical analyses where you might concentrate observations, and how are you going to sort of capture and record that? Maybe I'll toss, since Maciek, since you're on the line, why don't you have a first answer at that question, and then I'll go to Tasta.
Yep. So we looked at this effort as a global sustained observing system, and therefore the resolutions that we put in the specification sheets and that we think should be there are either existing capabilities or required capabilities, but looking at the global ocean as a whole. We did not focus on hotspots, or we did not divide between coastal and global, which is obviously what will happen, and probably these specification sheets will develop into some sort of division between basins or elements of the global ocean. But at the moment, we very much focus on it as a guidelines for the global ocean. Therefore, no focus on hotspots, upwelling regions, boundary currents, etc., etc.
Yeah, I just want to emphasize that this is the global ocean observing system, and there will be hotspots but we haven't identified these for the different UVs. It could be a good thing to include in these tables, possibly. For instance, one can think of nitrous oxide as being more important over oxygen minimum zones, or one can think about adding EOVs to certain regions. One can think about adding methane observations to the Arctic Ocean. So this is a base to build on for other observing systems that are more regionally focused. But that's a good idea to maybe include information on hotspots.
It's interesting. Just one more comment. I think I think the FU and this effort that we lead at the moment is not the only game in town. I think if we focus on the global ocean, there will be efforts that will be regional, hotspot oriented, basin oriented, etc. And they might have, you know, sub specification sheet, or they might be added as annexes to, let's say, the oxygen specification sheet will have 3 pages, and there will be a couple of pages of annexes. You know, what is the resolution if you look at this specific phenomena or this specific region. But I think that the main element should be approached globally so that it can be applied everywhere. Thank you.
So Tosta and Maciek, you've both emphasized that you're really looking at the global issues. And we have a question from Jay Perlman about the challenges of measuring open ocean biogeochemical properties versus coastal monitoring. Is there an aspect of the coast that's really a coastal observation that's important in global budgets and in understanding the global distribution of biogeochemical variables and how they'll evolve over time?
Maybe I can try
Tosta,
to give that
maybe?
a go. So there are significant fluxes of different biogeochemistry from the coast to the open ocean. Talking about nutrients, that directly related to the third question here of eutrophication pollution, for instance. Carbon fluxes tend to be large in the coastal ocean. If you are on the eastern border of the ocean, you may have upwelling, which are significant. So yes, there are definitely strong links to the coastal ocean here, and we need to be better at incorporating the coastal and marginal seas, oceans to the global ocean observing system, realizing that the signals that we see there are normally much bigger with much higher temporal and spatial variability, which makes it a little bit more complicated, but that could be accommodated for within the specification sheets here, that information.
You mentioned in the coastal ocean the signals are bigger, but the space and time scales are smaller. So does that make it easier or more difficult to observe in a globally systematic way?
I think that it makes it's both ways. I mean, you can operate there in with sensors that have slightly less of accuracy and precision and still capture the signal, but you need to have much more high temporal resolution on your measurements, obviously, and it's normally easier to get to physically. It's easier to get to the coastal site than to an offshore site. So it's both ways. It actually works both ways.
So both of you mentioned regional projects that will be looking at requirements on a regional basis for essential ocean variables or for ocean variables. And do you feel like what you have done here for the global scale applies directly? And how do you intend to work with different regional projects that are working on requirements and integrate them into global essential requirements for essential ocean variables? I'll throw that to you again, Tosta.
So far we do have some requests from various regional observing systems like the SOOS, the Southern Ocean Observing System, asking for input on essential ocean biogeochemical variables, and we are happy to be able to deliver at least a draft of that to them, realizing that this group may see have slightly different views on what is essential for that particular region. So I see that serving as a blueprint, as a base. This is kind of what you should do, probably even in your region, but you may be able to, and you should maybe add something to that. So that is how I see that, but also within the GOOS we have the global regional alliances, which we are talking together there. So I think through GOOS, that is a good way of talking to the regional observing systems. Thank you.
And so one last question, and again, I'll ask you, Tosta, is so these are requirements on essential ocean variables, and as you've mentioned, the different observing networks have different strengths in being able to respond to those requirements. How do you actually go from requirements on essential ocean variables to more pragmatic recommendations for what particular observing networks should measure, and what's the timescale you think that for biogeochemical variables you'll be able to do that?
Okay, that's a good question. I think that by defining the requirements and seeing what techniques are out there in an overview way, you can easily target what you would need to do. So for biogeochemistry, that would be development of sensors that have higher precision and accuracy than they maybe today have, because they are responding of high temporal and spatial timescales, and they are generally more inexpensive. So I think by just looking at this blueprint, looking at the requirement settings versus the observing networks and see where you find a match, and also looking at the readiness level of these things will actually guide you. And I think that is the idea about that by looking at these three things, you can be guided towards where you want to spend your money, where you want to invest in your observing system. It may not be sensors for all things, it may be different platforms and different observing networks, and it's probably going to be a combination of these networks. And most of us scientists working in these fields are aware of the spatial and temporal scales and the precision achievable with different observing elements. But when you are actually talking about the whole package of essential ocean variables, there are very few experts that have that overview. So I think of gathering this information in these 9 or 10 specification sheets that we're talking about could be very and will be very, very helpful for designing the observing system to get that kind of information. And that being said, we have to realize that this is going to be living documents as systems and technologies develop, and as science develops to refine the requirements, we may want to refine the specification sheets here to be able to respond to new science or to new technologies. I hope that answers your question, Albert.
Thanks, Tosta. It's a big challenge, and certainly the questions that we've been asked have pointed to some of the questions that the Goose Steering Committee as a whole will have to grapple with at its upcoming meeting. So I want to thank Maciek and Tosta for taking the time to speak with us, and encourage all of the audience members to take a look at the IOCCP.org website, which has these specification sheets, and provide input to both Maciek and to Tosta. I want to thank all the participants as well, particularly those who woke up early or stayed up late to join the teleconference. And we will be announcing the next Goose webinar via the mailing list. And you can join that mailing list by going to the Goose website, ioc-goose.org. So thank you very much. Thank you, Tosta, and thank you, Maciek.
Thank you very much, everyone.
Thank you very much for listening, and goodbye.